We had an introduction to this topic in the previous class. What we saw is we can have load sharing, load balancing, the traffic across multiple links, maximum of 32. Earlier it was 6 only. But by default, even if I have 100 equal cost path routes, only 4 will be in use, but we can increase up to 32. We can increase up to 32. But if you want to disable it, means I do not want load balancing, then what I should do? I should set the max path to 1, which means I do not want to do load balancing. So when there is a equal cost path to some network, if I go this way it is 10, if I go this way 10, if I go this way 10, all the 3 routes will be seen in the routing table to reach this destination 1.1.1.1. So when you type the routing table show IP route command, you will see 3 routes because all 3 have got the same metric. Equal cost load balancing is supported by default. But if you wish to disable it, you can set it to 1. By default it is set to 4. The max path by default is set to 4. If you set to 1, then any one of this link, random, it will use any one. But if you wish to increase more than 4, you can do that. Same command, max path, up to 32 you can increase. Which means if I have 32 equal cost path to the same destination, I can have all 32 routes in the routing table. So that when you send some packet, the packets will be load shared across multiple links. But when you try to go higher, like CCIE or the architectural paper, where I teach there, the routing protocol is giving you multiple routes in the routing table. Even though you have multiple routes in the routing table, for a single flow, only single link. What does that mean? If I have 1000 packets to send from A to B here, all 1000 will be using only one path. Even though the 4 paths are available in the routing table, only one path will be used. The reason is safe. I do not want to get into that area. That's not EIGRP. That's packet switching mechanism. If you disable safe, then you can expect the 1000 packets to be shared across multiple links, like 250 packet here, 250. But for that you need to have packet switching, not safe-based switching. That's not our area of study now. We are focusing on EIGRP. EIGRP will recommend up to 4 paths if the paths have got equal cost to the destination. Now, what if I don't have an equal cost? If it is equal cost, load sharing is possible in every routing protocol except BGP. Equal cost load balancing is possible in every routing protocol except BGP. What is special in EIGRP? EIGRP can support even unequal cost load balancing, which will be seen in the next page. EIGRP can support unequal cost load balancing. for which we need to increase the variance value. Meaning, by default, the variance is 1. By default, the variance is 1. What does that mean? Consider the routes whose metric is lower. If I have one path with 10 metric, another path with 12 metric, another path with 25, when variance is 1, it has to consider the path whose metric is lower, means only this path. If I have two paths with 10 and 10, then both will be considered. Why? Equal cost load balancing up to 4 is allowed by default. This variance cannot stop you using multiple paths. This variance is just to tell that take the lowest metric. See, that is why it is called as multiplier. Multiply with 1. What will be the answer? 10. All the roots that is equal to 10 or less than 10 should be considered. So only these two will be considered. But now you see, if I will change this variance, the default is 1. I cut this off. I say variance is 2. What does this mean? Take the lowest metric, multiply it by 2, and the answer is 20. Any path whose metric is less than 20 should be used for load balancing. This is what unequal cost load balancing. So now this path will also be included because less than or equal to 20, which means this. So 25 cannot be used because 10 multiplied by the variance value 2 gives you 20. 10 is the lowest metric. If I want to include this path, if I want this path also to be included in load sharing, please tell me what should I do? If I want to include this path, which is 25 metric, what should I do?
You will change the variance to 83, correct?
Wonderful. I need to just change the variance to 3. That's exactly right. Correct. So I have to change the variance to 3. If I change the variance to 3, I'll get 30. Now this is also included for load sharing. All 4 will be used for load sharing. So variance means the multiplier value. What is the default multiplier value? Only 1. That is why only equal cost load balancing is supported by default. But for unequal cost load balancing, we have to add the variance multiplier. See, it allows the router to include the roots with the metric smaller than the multiplier value times. If I say 3, then 3 times. If I say 2, then 2 times. With the minimum route to the destination. Any question on this page?
No questions.
Wonderful. Let's move on to the next one. Please pay attention to this example because it is covering something which we covered very long back. This example has got something which we learned on the second day of EIGRP class. Now to reach Z, to reach the network Z from E. From E to reach Z, we got three paths, one via B, another via C, another via D. The advertised distance via B is the metric of B. Metric of B is 10. So the total distance is the FD, which is this 20 plus 10 is 30. See, these things we learned earlier. Likewise, to go via C, the advertised distance is 10 and the metric between E and C is another 10. 10 plus 10 is 20. And here via D, the advertised distance is 25. The total metric is 25 plus 20 is 45. Now, please tell me which path will be the best path among these three. The one whose FD is lower. So this is the successor route. This is the lowest metric path, successor route. Now when I put variance 2, which means this 20 multiplied by 2, I get 40. So will this be used for load sharing? Yes, because it's less than 40. So this route can be used for load sharing. Now what about this route? This route cannot be used for two reasons. One, this multiplier value is less than this FD. The other reason is the advertised distance should be less than the successor value. Remember, feasibility condition is equal to the advertised distance of the alternate path, the backup path, should be less than the successor value. Is it true? Is 25 less than 20? No. False. It is greater. So D never, even if you change the variance to 3, when you say 3, you get 60. Even then, even the variance is 60, this route via D cannot be used. Why? This route will not be even seen in the topology table because it did not satisfy the feasibility condition. Feasibility condition is failed here. Is this clear? Take your time. Think once. And then if you're clear, you say clear. If you're having some doubt, please ask me. I'm sorry, I didn't get you fully. Can you repeat again, please?
Yeah. So the successor route, then E to Z, that would be primarily the success route.
Yeah.
And then to change the variance, it would still be utilized because it's still less than 20 times 3 variance that you are adding. 45 25 will not be seen because it's just higher.
Yeah. Now, see, even though when you change variance to 3 and the multiplier value is 60, still this cannot be used because of a different reason. It is because this route will not be considered by dual algorithm as a backup path. Only when the route is qualified as a backup path can be utilized by increasing the variance. This route will not be even considered. See, router D is never considered to get to Z because the advertised distance, which is 20 given by D, is greater than the successor value 20, which should not be greater. So for this reason, Even if you change variance, this path cannot be used. Is it clear? Thank you. All right. So we have to do this lab and see now. I'm starting from router 5 from the left. IP address is 5.5.5.5. Interface G3/0. IP address is 10.25.0.5. I'm giving for the host. I'm matching with the router's name. .5. Router is R5, so I say .5. 255.255.0.0. Interface G4/0. 10.35.0.5. Interface G5/0. 10.45.0.5. Then I write router EIGRP. Let's say autonomous system has 10 on every router. Network 5. Network. All the interface that runs 10. And write to memory. Done. This is what goes on router 5. I missed one command. Address. Alright. Now, show IP EIGRP interfaces. You can see the loopback interface and the gig Ethernet interfaces running EIGRP already under the autonomous system 10. Now I'm going to finish router 1. The reason is router 1 also has got 3 interfaces physical. There is no loopback, so I cut this loopback away. G3/0 will be 12.1. Because it's router 1, I'm giving router 1 as one host ID 1. And 13.1. 14, which is between router 1 and 4. 1. That's all. We don't need this because we don't have any loopback. Finish. This goes on router 1. Next. Router 2 has got 2 interfaces, 12.2 here on this side, and 4.0 will have 25.2. We don't have 5.0 interface on router 2, so I cut it off. That's it. There is no change under EIGRP because both the interfaces have got 10 as the first octet network. So router 2 is ready. Next is router 3. On router 3, G30 will have 13.3, and 35.3. There is nothing more to configure, so I paste it on router 3. One last router, then we will start our unequal cost load balancing. So on G3/0 here I got 14.4. Because it is router 4, I put 4 here and 45.4. Under EIGRP there is no change, so I just copy this and put it on router 4. That's all. Now we are going to go to router 1 to verify. I already see three neighbors. Router 2, router 3, router 4. You can also check it by typing show IP EIGRP neighbor. What is next? We are going to see there will be 3 routes in the routing table in order to reach 5.5.5.5. You see, for 5.5.5.5 you got 3 routes in the routing table. You may go via router 3, router 4 or router 2. The reason is all the paths have got same successor value. This is equal cost load balancing. We no need to do anything to get this. You need only the routing protocol. You no need to do extra tuning for equal cost load balancing as we do for unequal cost load balancing. Only for unequal cost load balancing we need to tune variance. Show IP protocol, you can see here by default the variance is 1, max path allowed is 4. If you want to change this is how you change. You see, what is the max path allowed? 4. How many paths we have in the routing table? 3. If I change it to 1, you see what happens. Router EIGRP 10 max path 1. What I am doing, I am disabling the default max path. Show IP protocol. See, I changed the max path to 1. Earlier it was 4. As a result, in the routing table show IP route, I have only 1 route via router 2. Earlier I had 3 routes via 2, 3 and 4. Now let us go back and put the max path to 32. Up to 32 you can do. Let us check whether anything higher is no. 32 is the maximum. 1 to 32. Now if you go back to protocol command, you will see up to 32 you have enabled, but the 32 is not needed in our topology. It's too much. Anyway, it's okay. That's not going to harm you. If you have 32 paths equal, we can have 32 paths in the routing table. That's what it means. So let us check the routing table show IP route. You can see there are 3 paths now. Though I have said 32, but available is only 3. Fine. Now let us see the topology table. Show IP EIGRP topology. In topology table also I see 3 successors. Why 3 successors? Because all 3 are receiving the same advertised distance and they got the same total distance. So 3 successor routes. This is what called as equal cost path load balancing. Now I'm going to make this unequal. Artificially, I'm going to make it unequal. How? By changing the bandwidth. Let us do one thing for our easy convenience. Let us go to every interface and set bandwidth as 10 manually. Let's do that first. I'll use a notepad to do this. On all routers, for one router I'll do it in the command line for sample. Interface G3/, there is also a range command, range G3/0, 4/0, 5/0. Oh, not allowed? Okay, I need to put G. Right now I am under all 3 interface. I can say bandwidth. What's the bandwidth we were talking about? 10. Manually I'm setting. I'll use do show history, and now I paste this on router 1. The reason why I'm doing this, so that we can have a clear understanding when I do some unequal cost. We will understand this better. Fine. So router 1 is configured, router 5 is configured. Let's now go to router 2. Router 2 needs only 5/0 is not needed, so I'll paste this in the notepad and I'll cut this off. And this is what going to go on router 2, 3 and 4. Alright. Now let us go to router 1 and verify. Even now router 1 should have 3 equal cost paths. I lost 5.5. Okay, here it is. 5.5.5.5. It says 2 successor. Give some time. Show IP EIGRP topology. Show IP route. For 5555, it is not showing via router 2. Give me some time. It should show. Also under loopback of router 5, I want to change this 10. Right. Going back to router 1. Why am I not seeing where router 2? I see only 2 routes. In the topology table it says I have 2 successors, but it is not showing them clearly. But there is a way. Topology for 5.5.5.5. 32. It shows very clearly now. The bandwidth is 10. I set it 10. You saw me doing it. Bandwidth is 10. Minimum bandwidth plus sum of delay is what it is going to consume. Sum of delay. This is via router 3, this is via router 4, via router 2, this is via router 2. Here it shows router 2, but when I type here it shows only 2 successors. How come? We got 3 successors. One via flag is 1, 2 successor. It says 2 successor, but it shows here 1, 2, 3. It is like that. Why it is like that? Composite metric. Everything looks similar, but 2 is not shown in the routing table. Show IP route EIGRP. I'm not able to see 2. It's not normal. Anyway, it is okay. So now let us not consider the 2 now. It has got some bugs. Let us not consider. Let us say we have 2 paths, and now both the paths have got equal metric. What I'm going to do is I'm going to make it unequal. How? I'm going to give here 20 as the bandwidth. When you make it as 20, or let us make it like this, not 20. Let's make 12, more bandwidth. More bandwidth, less metric. So router 4 should be successor after I do that. How do I do that? 12. On router 4, this goes on router 4. And on router 1, 5/0, bandwidth is 12. And also on router 5, router 5 is done. Router 1, router 1 is 12. What about router 5? Interface G 5/0, bandwidth 12. Alright. Because we have increased the bandwidth, the metric should have gone lower. On R1, if I check show route EIGRP, oh no, it still shows the same value. I don't see any big difference, though I change the metric. Oh no, I changed to 12, but it still shows 10 on router 4. Clear EIGRP address family IPv4 neighbors. I refreshed. I want to see once it comes back. It didn't form neighbor with router 2. Something is wrong with router 2. It has formed neighbor with 3 and 4. Show IP EIGRP neighbor. Oh, it is up. Show IP EIGRP topology. Now it shows 3 successors. Wonderful. So it was just a bug, okay? For my surprise, even though I changed the bandwidth higher, I still have this same value. Let me increase more. Bandwidth to 20 on router 4. And also on router 5 and 1. Okay, so what do we have now is we have this back router 2, and here we have 20, 20, all the rest are 10 and 10. As a result, show IP EIGRP topology. Sorry, it still shows the same value. Show IP EIGRP topology for 5.5.5/32. Wire router 4. How is that possible? I changed to 20. Yeah, I changed to 20, but in the output it shows it only 10. These are all bugs.